Hello and welcome to 5-Minute Math. Today we are looking at activities that teachers can use to reinforce concepts from TEKS 8.4c. This standard is talking about using data from a table or graph to determine the rate of change, or slope, and the y-intercept in mathematical and real-world problems. This is a blog post on my website, and I will share the link to this post in the video description. So this post starts off with some teaching videos, how we can find the slope and y-intercept in graphs, how we can find the slope and y-intercept in tables. The reason for this blog post and this video is because on the most recent STAR test 2023, our students across the state of Texas had some issues. So this is one problem, and as you can see, it is not multiple choice. It's a new item type. Students were given a graph with 2 points labeled. They needed to enter both the slope and the y-intercept, and they had to have both of those correctly to get the 1 point for this particular problem. And here is a video that you can watch to show how to solve this problem. Students also had to look at a table that described a real world situation, and they didn't label it y-intercept, they called it the initial amount. They didn't call it the slope, they called it the amount of money that Josh adds each month. So they had to identify which of these statements is true. Here's another video showing how to solve that problem. So that was difficult for some students. And all of the activities in this video follow this idea of active playful learning. What we want students to do is to have fun, to be engaged, to make meaningful connections, to be social, to have joy. It's not another set of worksheets or practice problems that is going to help our students understand the concept. So there's more context here. You can learn more about active playful learning here, but let's get to the activities. The video that I'm making is going to live right here underneath this title, and our first activity is called Countdown. So what we want students to do here is we want them to identify the slope and the y-intercept of a linear equation from a table, because that can be difficult for students. So we're going to put them in the students in pairs or groups of 4. It's countdown, so we're going to need some type of timer. And then you're going to give students a table of values for students to use when finding the rate of change in y-intercept. So here's some examples. I have it linked right here. And so here are the points that are available, right? So each group gets, or pair, depending on how you do it, there's 4 possible points. If they find the rate of change, they find the y-intercept, they write the equation in slope-intercept form, which should be fairly simple once they find these two, and an extra 4th point if they graph the equation. And then here are some examples, and these tables come from STAR released items. So I just copied them here for them, and all they're getting is just the table of values, and each one linked here that actually links to the actual larger problem. So what I did is I just ripped the table out. I didn't provide the context, which isn't necessarily needed. So they're finding those 4 items, and they're just going to try to see how many points they can get before the timer goes off for that problem. Now that's just the standard activity countdown. What gets interesting is we can start playing around with some of our extra point modifiers, right? So some of our extra point modifiers here will show that, I've got it right here, there we go. One of the extra point modifiers is going to be all or nothing. So it's an extra 3 points here. Teams must earn all 4 standard points using both methods, or they earn 0. So if they elect this extra point modifier before the activity starts, they have to get all 4. If they do, they get an extra 3, so that makes it 7, or they get nothing. Now, help means that students or pairs cannot help each other. They must earn at least 2 standard points individually. Blind nil means a team chooses 1 extra point modifier before seeing the table of values, and they earn all 4 standard points. So before they even see how difficult, quote unquote, the table is going to be, they choose an extra standard point. And then you see we've got some extra ones here. You can add to those as many as you want to. It's really just your choice. You can adjust them, add to them as you see fit. Keep a running tab of the points, so maybe it doesn't end in one day. You do this slowly over a week, over a month. You could switch partners so that students that are falling behind, they don't feel like they're stuck with students that are struggling. They just each earn individual points, or each student earns the points that the team earns. You keep track of it, keep it going for, a few weeks. Allow students to suggest their own extra point modifiers, add to the table of menu options. That could work. And if you teach multiple periods of math, have classes compete against each other, first period versus third period versus seventh period. So they either rise or they fall as a group. The next activity is called real-world linear relationships. We want students to create a table of values and a graph that demonstrates a linear relationship. For this activity, we are going to need graph paper, some index cards. What you want to do is you want to divide the class into 8 equal groups, and then give each group a real-world scenario to work with, and then 4 index cards per group. So here are the real-world linear relationships, and they're just separated here by each paragraph. And so these are just verbal descriptions of real world relationships here. So we'll take this one, right? The value of a car depreciates over time. A car is worth 35,000 when new, and 5 years later it is worth 25,000. Create a table of values and a graph that shows the rate of depreciation each year. For all of these, if they're not given, you can assume it is a constant rate of either growth or decay. One thing I would point out here is notice that miles per hour is bolded here. That's because the time is given in minutes. In 20 minutes, she runs 3 miles. We need that converted to miles per hour. So that's just one kind of wrinkle we threw in there. So we get one of these scenarios. This is what we do on the first index card. Students will write or glue the real world scenario, right? So you can decide how you want to format that for the students. The second index card, students will write the slope, so they're going to need to do some math on the side and write the slope m equals. The third index card, they will create a table of values, their choice as to what they want to choose for the x values. On the fourth index card, the students will draw a graph on the graph paper and then glue it onto the card. So what is a graph that would represent one of those? And then use the cards as review. So pull 2 cards at random and have the class identify whether they match or not. So there's a lot of review activities. This is just creating something from a real world situation, verbal description, how you can get a graph, a table, and identify obviously the slope here. So what are some variations? They can use the cards once they're created as a memory match, gameplay for review. You can divide the completed cards into sets of 3 or 4, with each set containing a matching real-world scenario, slope, table of values, and graph, and then have students separate the mix-up cards into matching groups, right? And then finally, groups can turn their scenarios into free response problems by creating a graph and table of values and asking the tester to find the slope. So these are kind of the stems of some problems. Every single problem says create a table of values and a graph. Students can use these to create, maybe provide a graph, provide a table of values, and then ask the tester to find the slope. So here's a third activity we have called graph exploration. We want students here to identify the y-intercept and the slope of a linear graph depicting a real-world relationship. So we want sticky notes as our materials here. Students are going to get into pairs. They're going to put a stack of sticky notes and a separate example of a graph. And so we've got that right here. So here is an example of a graph, and you can see this is just an image. This is from a STAR test, right? And and really what I did is I took off the question at the bottom, including the one thing that the test was asking for, and then the multiple choice options. So here is a graph, here's a real world relationship, and most of these are going to have the exact same. What was Maureen's initial deposit? How do you know? All of these are going to end with how do you know, because we want students to be able to justify their reasoning. How much does Maureen deposit in her savings account each month? How do you know? So basically, I'm asking for the y-intercept and the slope and evidence as to why, and we're just identifying it from a graph. This one, it is proportional, so if you want, you can ask, what was the starting amount of water, but it's pretty clear it's a 0 there. How much water is added every hour? How do you know? How much profit does Emily make from selling box of cards? How do you know? This one was from Star, but a graph was not provided, so I created one on Desmos. And then here we go. How many stamps was Carolyn given? So that's going to be your y-intercept. How many stamps will she buy every month? And it just moves on like this. You see some problems here with some Desmos, but we do have some label graphs. So that's it. Those are some graph exploration examples that we have here. Students are going to work together to answer the questions for each example. Now, this is where the sticky notes come in. Answers to the questions, either one or two, depending on whether the graph is proportional or not. Answers are placed on the sticky side of the sticky note and then added to the station so that their answers are face down. So each group is going to have a paper with this right here. That's why they're all on separate pages, right? You can just print this up. You can put this out there. They're going to write their answer on the back side of the sticky note and then stick it on the paper so that the answer is hidden. And then partners are going to rotate around the room, answering the question at each station, placing their answers on the sticky notes face down so the next group doesn't see immediately the answers of all the previous students that have gone through there. And then once partners have gone through all the stations, they go back to their original problem, and then they can check the work of everyone that rotated through there. So some variations are, if the partners get stuck, allow them to look at a sticky note. If a graph is two questions, have them place each answer on a separate sticky note. You can even color code those if you want to, one for the slope, one for the y-intercept. Have students add a table of values on a separate sticky note for each example if you want, and then give students a recording sheet. They add their answers to that and the sticky notes, and then at the end of class, reveal all the answers. Let students score their accuracy. And the way it's currently decided or currently depicted here, we're not necessarily tracking all the answers. Students are just participating, but if you want them to get some type of grade out of this, you can add that recording sheet. All right, our next activity is called Missing Table Data. So what we want students to do here is calculate the linear equation, represent it in a table, and use it to find missing information. So students are going to be in pairs or groups of three. You're going to give them each a table that shows incomplete data from a linear relationship. So let's look at these tables. And these tables are all just listed right here. And you're going to notice we have x and y, and we're always missing one x and then one y. So where they are in the table kind of changes. And that's perfectly fine because as long as you have one pair here of x, y, and then another pair within that same table, that's all you need to find the slope. Then you can substitute in other values to find the y-intercept and create your equation, and then you can use that to solve for the missing values here. So these are just all different tables with missing values. Students are going to use the slope and coordinate pair. Once they've used those two rows that include both an x and y coordinate, they're going to use the slope and a coordinate pair to find the y-intercept. Then they're going to write the equation in slope-intercept form. Then they're going to use that to, like I said, find the missing x value and the y value, and then have them rotate among groups, solve again. You can have them write on the table. If you only want to have one copy of the table, per group, then they write their answers on a separate sheet of paper. So what are some variations? This is a Google Doc, so you could easily just go ahead and just, adjust this as needed, right? You can have a missing x value and y value. Instead of that, have two missing x values, two missing y values. You can have students create a graph to represent the linear relationship. That's not necessarily required, but that is the next step if you want. You can make it a race. As they solve a table, students, send a representative to the teacher to get another table, and they keep going back and forth until each group has solved three tables. For extra support, you might give students a table with only one missing value, or with the linear equation given, right? That might be the first step. If they're not sure how to find missing values, first give them the linear equation. See if they can plug in the x or the y to find the missing values. Then maybe only give them one missing value, right? So maybe provide this x and they're just looking for that y right there. Those are some different variations. All right, our final game or activity here is called matching. Students are going to match the graph of a linear equation with 2 points, the slope, and the y-intercept. So here are some matching tiles, and I've got them right here, so you can cut them out if needed. And each row here has a complete set of a graph, 2 points, the slope, and the y-intercept. And down at the very bottom, I just have this as a visual reference, which is just the first set. So if you, once you cut this up, you might not remember what, the full set looks like. Here is the first set right there. So what we're going to do is pair students together, give each pair a copy of the matching tiles. They're going to cut them out, put the tiles into 4 piles based on the color or type. So your graphs are red, the coordinates are yellow, slope is blue, and the y-intercepts are green. They're going to work together to create a set of 4 cards. So once they're mixed up, they just need to find the match, right? They need to put those sets together to create this, this pair or this book of 4 here. And then that's the work right there, going over the answers as class. Lots of variation possibilities here. They can mix all the cards up and time themselves, see how long it takes to match up all the cards so that, test themselves. For a focus on calculating slope, you remove the graphs and the y-intercept cards and have students match just the coordinates with the slope, right? Because you notice that the slope here is given in this blue. So maybe you just want to focus on calculating the slope. And so all you're going to do is you're just going to give them these 2 cards, the yellow card and the blue card, because you can calculate the slope, right, from just the pair of coordinates, and that's all you need. For a focus on identifying the y-intercept from a graph, you remove the coordinates in the slope card, so you remove the yellow and the blue, and you're just giving them the red and the green. And you just want, it depends on what focus you want for that day. And then you can make a master of the copy or a copy of the master and have students create their own row using Desmos images, that's all this is right here. I just exported images from Desmos and inserted it into the table, and that's it. So students can do that on their own. So hopefully you will find some of these activities helpful to review concepts in 8.4C.